Okay, thank you, everybody. If you could take your seats. Apologies, there's only one door currently unlocked. We're going to try and do our best for lunch so that there's more entrance and exits if possible. Hope you had a nice coffee and some pastries and those types of things. So also welcome to everyone, or welcome back to everyone online. Sorry that we're currently running a little late, but we will do our best to make up some time. We're now going to begin a session that has a mix of speakers from both buildingSMART community, our practitioner course, a PCERT program, CIB, and some of BSI's team as well. So quite a mixed and diverse group of contribution here from different areas of expertise. Our first speakers will be Marina, Korol, and Hendricks, who are part of the openBIM Practitioner Task Force. And their title of openBIM Practitioner Goes International is our first presentation. Of course, we had this exciting announcement around Practitioner earlier. So quite a lot of firsts here, and we're really pleased to roll out this program and module within the program to support the industry. So with that, I'd like to hand over to Marina and Hans.
Hello, dear guests, online visitors, and organizers of buildingSMART International Summit in Marrakesh.
Hello.
I'm Marina Korol.
Yeah, my name is Hendricks, and we are here today as a task force for openBIM Practitioner, a really nice program, and we are on the stage to launch it internationally. So back to Marina.
The very fact that we are speaking in the session titled The Present and Not the Future is very meaningful, because openBIM Practitioner is ready, it's here, and it's set to global implementation by chapters around the world. So let's look at some of its key features. First of all, it's built fully upon buildingSMART standards and services. It's not about general BIM concepts or principles, nor is it focusing about national or profile or function requirements. Instead, it is structured strongly inside the core of openBIM process, which means it's about when information requirements are defined, when data is created, when data is enriched, checked, validated, shared, and all that while supporting communication among the project participants. What is especially particularly exciting about these standards and services, that they are either have been developed or updated very recently. And they are ready now to be put to work. And we strongly believe that to benefit from these innovations, existing processes must be optimized and new skills must be developed. And this is what can ensure that these innovations can be leveraged fully. The content of openBIM Practitioner is universal. It's not focusing on any national specifics or some profiles or roles. And as for target audience for openBIM Practitioner, it is aimed at a wide range of industry professionals, those who are engaged in production, coordination, and management of information across all the phases of built assets life cycle. To put it shortly, it is for those professionals deeply and actively engaged and in the heart of these processes. Now, let's turn things over to Hans so that he can lead us in quiz to gauge general awareness of this building smart services and standards in this audience.
Thank you, Marina. Yeah, the way we would like to do that is to participate you. This is not an exam, this is just a fun example. 3 questions, 5 minutes. So please join in with your phone. You can grab the QR code, but also you can go to menti.com and then use the code 14060397. So we will ask 3 questions. It's mainly fun, but we will represent the content of this program. And we have a nice bag of Dutch syrup waffles for the winner. So are you the first, the fastest? You will have this bag of syrup waffles. Hope everybody is in with the phone. Yeah, thank you. Ah, there are already 80, 90, almost 100 players already. Nice, really nice. I will try the boosten. So the question is about IFC entities. It's really important to have the right IFC entities. This question is about what IFC class this line on the road should be. You can scroll down on your phone because there are the 4 options available. It's about 20 seconds to go, so you have to pick the right IFC class. Fast. Oh, really nice. I'm really happy to see that the most have the correct answer. So that's really good to know. Let's see. Who was the fastest? Ricardo in front. Next question. Also here, how quicker you get, how much more points you will get. This is a question about BCF. What is the latest version of the BCF file format? Again, about 30 seconds to go. Also in the training and the exam, BCF will be used, of course, because it's an important standard for buildingSMART for the communication. Again, nice. The correct answer, of course, is BCF version 3. Let's see who's fast. There are familiar names in it. Jen. Jen is the fastest. Congrats. Let's continue. Last question. This question is about IDS. Also here, how faster you answer, how more points you will get. How many facets, this type of information, are defined in the IDS? 1, 3, 6, or 8 facets? Again, very nice done. 6 correctly. You can check entities, you can check classification, attributes, properties, material, part of relations. So 6 of them are included in IDS. Now it's deciding who's the fastest. Lex and Jen. I think Lex. Jen. Jen is the winner. We will bring you the back. Thank you for participating. Back to Marina. Oh, you switched it already.
No.
You can go back here.
This one. Okay, let's continue with the more or less theoretical part. So,
yeah, there was different. There was a difference, but you can scroll down.
oh my God, yeah. Okay. openBIM Practitioner is training and certification program. Let's start with training. It's important to note that this program is not for beginners, it's for practitioners. However, we identified a significant skills gap in the industry, and we needed to address that. That's why we included a robust training component into the program. And our goal is to bridge this gap with hands-on learning and training while disseminating knowledge in the industry and upskilling professionals. Before we started development of this training content, we took a deep dive into the process and looked at the tasks which practitioners, which professionals normally perform. And we identified the list of tasks, actually, and identified the competencies which are needed to successfully execute those tasks. And that led us to build the learning outcome framework. And let me give you an example, a practical example. One of the tasks is actually analysis of project information requirements, and corresponding competence is the ability to analyze project information requirements and map appropriate IFC entities and buildingSMART data dictionary classes. And this ensures that project needs are met and requirements of information of international standards of data exchange and interoperability are also met. And this approach of linking the tasks to the competencies helped us to shape the whole content of the program. Now I'll hand it over to Hans so that he illustrates our approach to the training. Please, Hans.
Thank you, Marina. Before deeping diving in the training, I would love to show you the learning outcomes. There are 5 modules, 29 topics in total. I will not mention all of them, but maybe the 5 important, because you will remember Clive's presentation. Clive had a nice workflow presented this morning. It's about openBIM knowledge, but also then you should be able to have a clear requirements definition, then the openBIM data production, then you do the model check and the validation, and also the collaboration and management afterwards. I show you just 2 simple examples, what you could expect in the training. So from the learning outcomes, just an example, maybe you recognize that from practice. A lot of cases you get the specs unstructured. They are in all kinds of formats, Excel or whatever, and they are not quite capable to check. After the training, you should be capable to have an IDS made out of that specification, so that the IDS is very clear, machine readable, and very consistent. Another example, it's about filtering and selecting objects. When there is a data set, you should be able to filter, select objects, and communicate with others, stakeholders with BCF. So in this specific case, select all the IFC railings and communicate with another one in BCF file format. This is also just an example what you could expect in this curriculum. Then I'm excited about showing you the data set. This data set is especially created for this curriculum. It's built up with tiles, so different parts, and it's modular. So you can see, for example, there's a part for infrastructure with a road, but there is also a tile with a building, and within this tile, it's split up with the architectural, structural, MMP aspect models. And it's meant also to share knowledge between the domains, but also to use this in the training exercises. So back to you, Marina.
Okay, we looked a bit at the training part. Now let's shift our focus to certification. From the very beginning of development of this program, we made a goal for us that it should be fully compliant with the requirements of the standard ISO 17024. And those of you in the audience who are familiar with the standards are now, I think, sighing sympathetically, and for the good reason. Yes, we developed a certification scheme, and we established the following prerequisites for the certification: a foundation certificate, completion of the openBIM practitioner training in one of the registered training providers, and also 2 years of practical experience minimum. Because it's certification program, and compared with a foundation, which is qualification program, there are a lot of arrangements needed to even before certification start, even before the exam. But it is exam, I think, I'm guessing, that attracts more of your attention, picks most of your interest. So I will hand it over to Hans again, so that he will lead us in examination details.
Thank you, Marina. Yeah, I keep it short about the exam. The exam is an online platform. It's built up with questions, but also you have specific tasks, uploading files, downloading files, etc. In total, it will cost 2 hours for this core content. What can you expect? This is just an example. It's not only multiple choice question, but you have also to do, in this specific case, you have to drag and drop a correct answer to a correct spot in the exam content. So I'm really excited about the exam. Let's give it back to Marina.
Okay. As we have already mentioned, it is a content which is universally applicable and was designed to be applicable globally. It does not contain it does not contain national specifics. So you have seen the data sets, right? They are impressive, I guess, for you, and something unexpected you have seen. So the content is ready for global implementation. But as for the adaptation, which is needed, actually, it is translation of the text content of it, which is normally handled by chapters. And these data sets, this content does not require a lot of adaptation. As you have noticed, probably the data does not adhere to any building codes of any country, and there is no need to translate properties or values of the entities in this data set. So at the same time, we recognize that regional markets have their unique needs. And for that, we developed a framework which allows chapters to supplement our international core content with their national specific materials. And that will help us to ensure that our certification is very well tailored to the market needs. There is much more we would like to share with you today. But I'm afraid we are running out of time, and that's why we are cordially inviting you to join us tomorrow at the session which will be dedicated totally to chapters implementation at 4:30. So there will be a more interactive part where we can discuss how to implement, and we'll be able to answer your questions and get your feedback. And last but not least, actually, maybe you have noticed I said very often we, but saying we, I didn't mean Hans and myself. This is a large group of contributors. It is the whole community who made this happen. And I would like to mention the teams. It's buildingSMART teams, it's leadership and management office. It's actually buildingSMART technical team. It's our pilot chapters, Germany, Austria, and Italy. And a lot of experts were involved in expert in specific services or standards of buildingSMART. It's also openBIM education experts. a lot of reviewers and testers were participating and are still participating in finalizing the testing. And also we'd like to specifically mention the CRBIM Alliance, who are actively participated in various stages of this project development. With that, we owe big thank you to all of these mentioned people and to you, dear audience.
Thank you.
Thank you.
You can tell me. Yeah, but it's good. Yeah. Because we have big milestones now with the ministry. And
thank you very much. And I think, yeah, congratulations to Celine and to see Mark as well, the team. A lot of contributors here in the room, and really it's amazing to see how far we've come with this program, and it's a pretty big milestone today. So well done, and thank you very much. All right, so next up we have a speaker from the CIB program. Simon Fischer is part of the Technical University of Wien, and he's going to be presenting on open standards in the code compliance checking process. So Simon, over to you, please.
Thank you. So thank you very much for the introduction. I guess you can hear me. So yeah, this session is all about the present. And the abstract of the session already mentions some very interesting topics we have at the moment, like code compliance checking and e-permits, but also developments in the open standards like IFC and IDS. So to combine these topics, I will present how my colleagues and I approach the development of automated solutions for code compliance checking, and especially how we benefit from the use of open standards. Okay. Now it works. Perfect. So one of the big benefits of using BIM models is the availability of digital building data. And we can analyze this data, for example, for code compliance checking, but also for other use cases like thermal simulations or sustainability calculations or anything else you have in mind. However, to ensure we have the right and the complete data available, we need to define information requirements first. This is a very important step because the best algorithms are useless if we don't have the right data available. And then afterwards, we get calculation results, and we can process these results further. So this is the generally applicable process for us to analyze information from BIM models. And I will describe this process a little bit more in detail on the example of the escape route analysis we developed for the code compliance checking of Austrian building regulations. And you will see the basis is always the use of open standards. First, a little bit of background information about the escape route analysis to understand the complexity of it and the challenges we have with the escape route analysis. So it concerns elements that are not explicitly contained in a building model. So you can see we have here geometry in building models of spaces, of doors, and so on. And we also have additional information like how many people are inside the room or what fire resistance does this object have. But normally, the escape routes themselves are not drawn or modeled into the BIM model. So the escape route analysis generates new information from the implicitly contained information. So we have new elements here, the escape routes themselves. And the escape route analysis is quite complex because we have multiple options where escape routes, where the individual routes can go, and they influence each other. So we have a dependence on the number of persons that use a particular path. For example, they pass a door, and then the width requirements for this door changes. So if we use here, for example, for the bottom right door, we use the orange and the blue path. We have different width requirements, and we use the orange and the green one because then the persons are split. So then we go into our workflow and start with information requirements. And we'll do this on the example of IFC space because it is, together with IFC door, the most important basis because it defines geometry that we need, and it has additional information, like I said, the number of people that try to escape from a specific area. So we have some properties we need in our BIM model to do these calculations. For example, I have here 3 properties, and normally, or by now, information requirements were defined for all objects of one entity mostly. So all IFC spaces, for this example, need a space category. But we can define this more targeted. For example, the occupancy number and the staircase type is only necessary if the space category has a particular value. So the necessity of one property is dependent on the value of another property. And we can define this with IDS, because we can define a very targeted applicability. Like we heard from the first presentation here, we can have attributes, properties, classifications, and relations that define which elements are really applicable. So IDS allows us to define very targeted information requirements, and that it reduces by this the information, the unnecessary information we have in building models. And then, of course, it's computer interpretable and allows us to include it into automated solutions. And it's open and standardized. And this is a very important fact for co-compliance checking and building authorities, because at least in Austria, it's the fact that a building authority cannot dictate a closed system, because some applicants would have advantages and others would have disadvantages from them. So for automated compliance checking, IDS is really a strong tool for defining information requirements. So next to the next step, the checking and simulation. And here for the escape route analysis, we have 3 steps again. We generate an Indo navigation model, apply a pathfinding algorithm, and then check the elements along the escape routes if the width is correct. And of course, the 2 last points is an iterative process. So for the Indo navigation model, we start from an IFC model. We have the geometry we need there. And then by turning the continuous space we have inside a building into a graph network, we create an abstract system that is applicable to have a pathfinding algorithm on that. So let's get a little bit more into detail here. A graph network consists of nodes and edges. So the nodes are fixed points. We have here nodes inside the room. These are placed at the corners, the convex corner nodes and the concave corner nodes. The convex corner nodes are needed for start rooms because we always start at the most remote point in a room. And the concave corner nodes are then necessary to navigate through a room, because when you pass a room, you would never go into a convex corner, because this is always a deviation. And then at last we have door nodes and as well stair nodes, which connect different spaces with each other. The next step is the edge creation. So an edge is like the direct connection between nodes. And in our concept, this is visibility based. So if I stand here and can look at a certain point with a direct connection, I can go there. But as you can see here, with this approach, I go directly at the corner of the room. And actually nobody can go really at this corner, because we all require a bit like a zone or a width around this connection. So we created the flexible tube, which is a zone around the shortest connection that can be switched from one side of the direct connection to the other to create a zone that checks if around the direct connection is enough space for people to actually walk there. And this works also for a bit more complex geometry. So you can see with this, we combine the shortest possible path and a realistic width check. And this is all based on the IFC model we had at the beginning. So then we come to the pathfinding, and the pathfinding is applied to the abstract model. So you can see here for the 4 different shortest path options, we have the different nodes in there, and the path goes along the nodes. And we now overlaid it with the floor plan to have a little bit of an orientation. But this really happens in the abstract in the navigation model. And finally, for the element checking, we go back to the IFC model. And if a route passes a particular door, for example, as we have it here, we retrieve the information we need from the IFC model. So here, the width of the door, the height of the door, and the direction. And we can then check if this is compliant with the building requirements, with the building code requirements. So we're now with the last step, the result processing. And as I already started with that, we start from escape route information implicitly contained in the IFC model, and we create new explicit elements for escape routes. But this new information is included in the system we used for the calculation. So this information is in a native format, in a closed system. And the goal now is to bring these results into the open IFC model. And this promises great benefits for, on the one hand, reusing this information for other use cases, as they may use different software, and then we need an open format. And as well, the long-term archiving of information. This is very important for building authorities, because these escape routes is permitted data. So they said this is permitted, and therefore we need to access this information in decades. It's pretty similar to paper-based plans. So we can access these plans also in decades, and this can be done by IFC 2. So we proposed the generation of a new IFC escape route domain model. And in this model, we want to save the crucial information about escape routes, which is the geometry and some characteristics or features that are very relevant for code checking. So at first, we have segments, which are like the edges of the graph network I had before. These are direct connections between corners. And for these segments, a very important property is the number of persons that use the segment. Because here we sum up the persons and have then the relevant number of persons for the width check. And then we have an escape route which combines different segments to a continuous path. And the different escape routes can use different segments, and the segment can be used in different escape routes. And here the crucial information is the escape route length, because this is most often defined in building code. So here we are with our IFC mapping. How did we represent this in IFC? And here on the right side, for the segment, we use the IFC spatial zone. Like I said before, an escape route is like a zone. We need a width and a height. Even though we did not represent it here with the geometry, the meaning of the entity fits very well here. And we have a property with the cumulative number of people that use that segment. And then we have a mapping for the routes, and here we use the IFC group. Because the IFC group can combine different segments, and here as well, different segments can be in one group, so it's no problem to have one element assigned to different groups. And as well, an IFC group can have properties as any other entity. So we have here the escape route length as a property, and the people that start the route and the start location as additional information. And I want to emphasize here the capabilities of IFC, because during the process of finding a suitable IFC mappings for our use case, it was really impressive to see what information about buildings you can represent with IFC. So I guess if you have other use case where you want to represent information in IFC, you probably find a suitable IFC mapping. Yeah, here just a little impression what you can do with different visualization options. So here we focused on the flow of the people to see how near you get to the exit, that here the people come together and we have a bigger flow of people there. This visualizes the data much better than we have it before implicitly in the building model. And when you create new IFC data, one of the most important things is to ensure IFC conformity, that you are conform with the standard. Because if you're not conform, using a standardized system is useless because you are not using it anymore. So we used the buildingSMART validation service to check different mapping options we had here. So as you can see with the buildingSMART validation service, we can check the step syntax, the IFC schema, normative rules, and some other things, but they were not relevant for our use case. And we have here different problems with our 5 options. You can see I said 5 options, but we have 6 lines because the last 2 both concern the IFC group mapping I described before, but the second last is in IFC 4, and we have an error there, and the last one is then in IFC 4.3. So let's have a little look on this error. We wanted to assign IFC group to the spatial structure, and this was not possible in IFC 4 because only child entities of IFC product are allowed to be assigned. But this problem was fixed in IFC 4.3. And I think this really highlights the benefits to stay up to date and use really the newest developments, because IFC is evolving and this getting better and better from time to time. So really use the newest developments here. Finally, we made it through the process of information requirements, checking and simulation, and processing the results. And IDS was the key to define targeted information requirements. And these can be included into automated solutions. Then IFC was the basis to perform complex computations and generate new explicit data from implicitly contained information before. And finally, IFC ensures or helps to archive data. And this is by generating new BIM domain models for new use cases. And here, the buildingSMART validation service is a really strong tool to ensure your data is correct. And we showed with our example, escape route analysis, that how this process actually works and how we benefit from open standards here. And this process is not only applicable to escape route analysis, it is applicable to any complex computation you want to perform. So you always have to first define information requirements, and you always can bring back your results into the openBIM workflow by saving them in IFC. And as the title of our session says, this is the present. If anyone wants to dive a little bit deeper into this, we have already published some papers on that, and we also published some IFC test models, some generated domain models, and source code for our domain model generator. So please feel free to reuse the stuff. Thank you.
Thank you, Simon. Wonderful. Wonderful use of the openBIM workflow is, as he mentioned, applied to the present and sort of connects nicely with what we saw with professional certification, where we develop training now to support the use cases that are also being developed as well at the same time. So fantastic examples there. All right, next up we have Jaan Saar from Future Insight. He's the Chief Evangelist at Future Insight. His presentation is on automating building permitting, the killer app for BIM. So Jaan, over to you.
Thanks. Well, hello. Nice to see all of you here. And it's an honor and a pleasure to really be on stage here at the buildingSMART Summit. It's also a little bit intimidating, to be honest, because I'm not a technical guy. And I like coming to these summits because then I feel I'm surrounded by smarter people, which means you're most smarter than me. And this is great because I can learn so much. But it is, on the other hand, it is also intimidating because I my presentation, my slides, are maybe slightly more simple, and they look at the problem we're facing from a slightly higher level. So, but you can be the judge of it, whether or not I do a good job or not. But I hope you will find something insightful from this presentation. And it's interesting that we put the BIM-based permitting stuff into the present session. And this is a very technical point of view. Indeed, we are talking about the present. As you saw from the previous presentation, as you'll see from my presentation, the technology is there. But if we look at the implementation aspect, then this is all future. We have very few implementation cases. And technology, yes, it's ready, it's the present, but we are very, very far yet from actual, real, large-scale implementation. But hopefully, we can fix that. A little bit about me. Yeah, because I said I feel intimidated being on this stage, so I had to put some logos and a nice picture of me. But I am working with governments, non-profit organizations. I used to be, until the beginning of this year, head of digital construction for Estonia, a very digital country, etc., blah, blah, blah. But currently, I'm working with Future Insight, and we're developing solutions and helping governments and municipalities and companies also to implement some of this cool technology that is already there, but not yet implemented. Okay, but let's take a wider look at the challenge in front of us. So we often talk about the technical aspects, but are we really looking at why we are doing this? And although there's a lot of technical challenges, you know, complicated stuff, we can talk about all the different standards. buildingSMART is doing great standards, by the way. But what are we solving? The real challenge is this. We're facing a climate crisis. I think nobody can really deny that anymore. More extreme weather conditions, floods, fires, and also we're facing, due to this climate crisis, mass migrations. And we are facing at the same time a huge housing crisis across the world, everywhere. So we really need to learn how we can build better and faster, and also improve the living conditions. And, you know, construction industry is not known for being the most effective or productive or the most efficient in the world. But okay, in this buildingSMART community, we of course see, I would say, the topping on the cake, which is really the front runners, really the innovators pushing the industry forward. But if you look back at the majority of the industry, we are far from implementing all this cool stuff that we've been actually talking about for years and years, in some cases even decades, as it comes to BIM. And of course, what companies, governments, clients are facing is digital transformation. And all companies are becoming technology companies. And how can we really tackle these issues? And again, the technology is there, but how do we implement? So where do building permits come into play when we look at the bigger picture? Building permits are, well, I wouldn't say a necessary evil, but they are required. But they're not, you know, a process somebody's really looking forward to. It's something you have to get out of the way to start building. But you need permits to ensure safety, legality, and efficient resource use. And it is really a key process in getting a design, an idea into reality. So if we're talking about digital twins, then they're the reflection of the physical assets, but how to get from the digital to the physical. And the building permitting process sits right there in the middle. And it is often overlooked, but again, it is also an opportunity. But currently, it is expensive, it is time-consuming, it is rather complex. And it's always different from whichever country, municipality you go to. It's a lot depending on people. And the solution is, right now, just brute forcing it, you know, putting more people at it, putting more money, manpower, etc. And that's how governments are trying to solve the issue. But there is a better way, of course. And well, you already know the answer, but let me take you through the story. Just to see a raise of hands, how many people of you know the term killer app? What is a killer app? Just raise your hand. Have you heard the story? Okay. I knew I was with smart people because this is more hands than I get usually when I'm talking about this. But just to go through the definition, a killer app is usually a software product that is so good that it actually makes you want to use an entire ecosystem, or you want to use all the other relevant hardware software associated with it, just because of this one use case. Some examples. VisiCalc, first spreadsheet program for the personal computer. And this was the killer app for the computer. Now, Excel wasn't the first spreadsheet app, VisiCalc was. But this, well, everybody uses Excel in the end of the day. Let's be honest, when you boil down our work, every single one of us is working on a spreadsheet at least a couple of times a week. And VisiCalc started it, and that is why we have personal computers, essentially. It was one of the killer apps that made every office and company want to use a personal computer. They saw the benefit. Desktop publishing applications. This was a killer app for the graphical user interface. Before that, computers were line-based. Many of you remember them. Some of you have read about them or seen videos about them. But before Apple revolutionized with the Mac, the interface, how we interface with the computer, the killer app really that got things rolling was desktop publishing. So you could really see what you're doing, and you could replace all these huge and complicated equipment related with doing layouting and printing and all of that, and prototyping and etc. And along with the laser writer, which was the laser printer, this was a real killer app combo and got the thing started. For the internet, the jury's still out on that one. What is the killer app there? Some say it's email, some say it's the HTML language, but for sure, both of them were one of the reasons why we started really using internet. And email is a good example. The iPhone, the killer app there for the iPhone was actually the App Store. And even Apple didn't realize it immediately. For BIM, I honestly believe automated BIM-based building permits are a killer app because they help to automate and improve the very complicated process. And they bring the value of this data, of BIM technology, to a whole new group of stakeholders who really haven't had a chance to get any value out of it. So let's take a look at a case. Estonia. Estonia has had a digital building permit process already since 2016, a PDF-based, drawings-based, you upload files. This is what a building permit looks like. Digital container with an automatically generated PDF that is digitally signed. And when we developed the building registry is the system that is used across Estonia to manage all building permits, we saw that it is also a repository of built environment data for the government of Estonia, for official data. And yeah, you can do statistics, you can get data from it. But more importantly, the building registry is at the center of communication between all these different stakeholders. And it is not just one-way communication, it is actually two-way communication. And we started adding more and more data to the building registry, also energy labels, for example. And you saw that the whole process with communicating and getting approval, getting feedback, it was involving all the municipalities, the fire safety, the land registry, the utility companies, the real estate companies, and it was really becoming something more than just a building registry. So we adopted the idea that we should turn it into a platform. And we can use the building registry to really enable the exchange of standardized and trustworthy data between all stakeholders. And we wanted to use BIM at every possible case we could imagine. And the idea was to make public processes faster. And to kind of explain the idea of the e-construction platform, it's better to do it more visually. Here you have a classical setup of a database, services, and user interface. And these were kind of the first services that the building registry had. We started expanding them, adding a utility network database, BIM-based permitting, which I'm going to talk about just a bit more. We created a national digital twin, which was able to visualize different sources of data and had its own services, like you could download data and stuff. And this meant we were creating or connecting a lot more databases. But it wasn't a super database. It was really a distributed architecture that we were using with microservices. And you see, we have a whole bunch of services. And the pink bars in both of the ends, they represent the opportunity for the private sector services also to connect to this platform. But the platform itself is formed from this service layer. And it is actually nothing more than a set of agreements between these services. So you need, as much as possible, a common language, standards. You need a common architecture, at least to some extent, to enable API data exchange. And most importantly, you need a common philosophy, that we come out of our silos and we open up our data and services to others. And the Estonian case is very difficult maybe to replicate because it's very Estonian government-centric. It depends a lot on e-government systems that were already there in place, that were really first time developed anywhere in the world in Estonia, but they're bespoke. But with Future Insight, we kind of have the same concept with the Clearly Hub, which is also a platform solution that connects services and data. But this is not what I want to talk about today in more detail. What I want to talk about is the building permitting. And of course, open standards are at the heart of everything we do at Future Insight and also at the Estonian government. And I think every government should be looking at open standards, not just openBIM, but also other standards. So we need to think a bit more widely. But the fact is, international open standards are the inherent way to ensure interoperability between different systems. And I have a nice video of the functionality for the BIM-based permit checking, but unfortunately, we don't have time to really go through it. I'm going to let it run a few minutes, so at least see the interface. But the idea was to have a self-service platform, so the applicant can go, run the checks, upload an IFC, run the checks, get a BCF back from the result of the checks, take it to his team, work on the model, run it again, and only when they're happy enough, they push a button and the municipality gets notified, oh, somebody wants to apply for a permit. And it's integrated into the building registry, so it's not a standalone system, but it's an online system, cloud-based, and it is, the key there is to make it as simple as possible to use. So taking away as many buttons, hiding the complexity, so it is just there to add value for all the people involved in reviewing, in making sure whether or not this building should be built, is safe and meets requirements. And of course, you need to put it into context, etc. But you can check out the video on your own if you Google it or if you go to Future Insight website. But to summarize, why we need BIM-based building permits. Speed. It can make the process faster. And in many cases, we're talking about not weeks, but months to get a permit. And this is all time we should be spending better to use elsewhere. Transparency. When you automate it, it becomes more transparent. Quality, because it improves the design quality before it reaches the desk of the municipal worker, it is already ensured that you're compliant with A, B, and C. And quickly to go through some of the lessons learned, we did this in Estonia, we also are doing it in Finland and in other places. You need to choose the right checks to start with. BIM requirements are really integral to the whole point, and you need to make them simple, not more complex. Because in the end, you need to show why the modelers, the designers, the engineers need to put the data into their BIM model. You need to use a multidisciplinary team. IFC alone is not enough. And yeah, that's an honest statement. This is what we've learned from practice. You need other standards. You need other sources of data. But you need to be working in an agile manner. And if you want to know more about some of these lessons learned, you should check out this session on, I think it was not tomorrow, but on Thursday. And there's a nice paper about also digital permit checking and many of these lessons learned. But the biggest challenge is implementation. So the technology is there, but we need to implement it. And I know I'm running out of time, and Aiden is becoming really nervous over there. But just give me one more minute, Aiden, to wrap up. But I see things are moving. The rock is about at the edge of the cliff. So in terms of implementation, we are also now entering a stage where I believe the technology is mature enough. It is already getting more simple to use and to implement. And we're seeing this across Europe. 57% of municipalities, according to a recent survey, are planning to implement BIM in their building permit system. And yeah, buildingSMART already recognized this technology as one of the front runners already back several years ago. There's a network of digital building permitting. There's several Horizon research projects. We're involved with Awkward. buildingSMART is involved in both Awkward and Check, and we're going to hear about Check in just a minute. We have the EU BIM task group, where we see a lot of countries working on this problem, trying to solve it. And we also had a conference in Barcelona dedicated to building permitting, mostly academic, I agree, but also some already very practical use cases. And we're going to have this conference again next year in Vienna. So collaboration, well, skipped one. You were already hoping for the last slide. Sorry. But we need collaboration between private and public. But my main message is still, technology is ready, start implementing today, and use international open standards. Be bold, be prepared to fail. You are going to fail, but fail fast. Okay, but that's it. Thank you, guys.
Thank you, Jaan. Lovely segue then into the next presentation, and certainly some good thoughts as we move into the final presentation for this session. Right, next up we have Siham El Yamani, who's the project coordinator for Horizon Europe at Czech, which we mentioned just a second ago. And this presentation is titled Building the Future of Digital Permits, Czech DBP. So Siham, over to you, please.
Thank you, Aiden. Not sure it's working. Yeah. Hello, everyone. Congratulations. You made it to the last session before lunch so far. I'm really glad to add for this presentation a vision from the geo background side to the BIM side. We've talked in the last presentation on the BIM Clearly project, which is also a part of a sister project to Horizon project for digital building permits. But before to dive into my presentation, I'm really glad to be here on the stage because I'm from Morocco, and 13 years ago, I've been on the school at EAV Hassan II Institute, and as engineer in geometric backgrounds field. So yeah, it looks like yesterday, but today I am gonna bring the future to the present through a huge project that we are working on different municipalities through Europe in order to digitalize the building permits. We have 5 aspects: the innovation, the process, interoperability, the technology, and the scalability. So we've seen that the solution, it's not enough, but we handle other aspects to complement the solution itself. Not sure if it's working. Check, yes. So we are a consortium composed of 19 European countries, and the coordination and the management part is between the OGC, Standardization Organization, and TU Delft, where I am based. We have buildingSMART as a part of the consortium, which made it really enriching on the best practices and standardization part. For the software companies, we have large software vendors from the SIP and the BIM server parts to the virtual city system on the level of the city sites. Few other solutions like Synapse and RDF and Dirodes. From the research part of universities, we have TU Delft group for the solution BIM to Geo conversion, Fraunhofer and University of Brescia and Minho for the Czech compliance coding, and EI for rule interpretations. Designers, which are also one of the key parts of the process to validate digital building permits. We have two companies that are designer-based and BIM manager in the meantime, so that we can implement the data requirements and the modeling guidelines for the digital building permits at early stages. Constructions, we have also their interventions in the consortium, and by the end, also the key to the challenge, municipalities, we have 4 use cases to make sure we have the challenge of regulation scalabilities from 3 countries. Ascoli Piceno from Italy, we have 2 municipalities in Portugal, Gaia and Lisbon, and we have also Prague municipality to make sure that in the digitalization process, we take in the context, the regulations challenges. So as I said, it's so important for today's summit to point out the relevant partner at the BIM side that we have in this consortium. So we are all over the Europe, so we make sure to meet once a year to make sure that we get out of the online progress meetings. This one was like 2 years ago in Delft, and we were just 2 weeks ago in Italy to make sure we present and we collaborate with each other the outcomes of the project. And from the parts of my team that I'm representing also, these are 3 developers that are participating into the solution itself. So Amir, Jasper, and Ken, I'm gonna present one of their solutions, so credits to them. And on the management and coordination parts, we have Francesca, the founder of the project, and she is now on maternity leave, taking care of another Czech project baby, so that I can help her to take care of the Czech project itself. So I'm replacing her for 5 months. Huge responsibility and honor, of course. And Jentin's daughter for the advising part in the coordination. So getting back to why this consortium is born is to solve few common issues that has been detected in the history and the journey of the digital building permit. So let's take step by step few issues and challenges that has been detected. We have as we said, the process. The challenge in the process is many bureaucratic tasks that needed to be validated through public authorities and private authorities from the designing phase, and what can be digitalized and accelerated at this phase until the municipality phase and approbation. Not everybody had the skills to use both BIM to geo-site solutions, specifically that we talk about softwares, standardization, data exchange, and then the tools that are now created. So this consortium brings not only the knowledge and the solution, but trainings and workshops to municipalities and designers to help them achieve the understanding and the usefulness of the tools. Talking about softwares, we are talking today about the BIM side, but from the GIS side, we have licensing, ArcGIS, QGIS, but to help municipalities into the transition with the tools that we are using, which is the software toolkit I'm going to present, we need to standardize the workflow. So what's going to be used during the workflow at the municipality stage, and also to make sure that they not have one solution. We made sure that we have also other partners that develop other solutions, and the choice is up to also municipalities to validate and to extend the usefulness of the softwares. Different context. We are not talking, as I'm repeating, about the solution itself. We have the Italian context. Regulation is natively written in different languages. We have the daily basis technicalities, how the technicians, how the agents are interpreting the rules themselves. And we have also how far this mapping can be done from both sides, for the IFC and from the CityGML or CityJSON standards, and how the data exchange can be done so far for these different municipalities. So the challenge is so real. We've been so ambitious in terms of scalability, but one of the things that are so important is not to try to adapt one approach for the mapping or rule interpretation, but to take first from the context itself and to analyze each rule, and then we can come up with common parts in the scalability. So to summarize, this project came to achieve these objectives, talking about how far we can simplify bureaucratic tasks and data exchange process and technology. We tackled this part by developing from TU Delft 2 solutions that are supporting openBIM and that make sure that data exchange is there. And from research perspective, these solutions are open source, and you will get the chance to get them from Depot. Providing trainings, it is at the stage of the project, we already done 2 workshops for municipalities and for the community of practice, which are like an advisory board, people that are supporting and helping us with best practices and also getting feedback from them. We already planned 2 workshops that will be public on the website of CheckTPP. Scalability as standardization. The output of this project by the end of next year, we have dedicated task to report in collaboration with BIM, buildingSMART, and OGC, how far we can extend the next versions based on the outcomes of the project. So how this started first? The first year has been challenging in terms of what are the categories of regulations that can be tested. We've started with mini regulations from the indoors to the surrounding of areas, but then after 1 year of interpretations, we make sure that we focus for the 4 municipalities on 4 categories at first. So first of all, distances. How can we compute for a new building distances from the building openings to the road, to the sidewalk, to the next building, or to the next building openings? How can we automate these chickens and how far they can be automated? Taking the example of the maximum building height, it was really challenging because this is not related to the definition of the computations, but getting back from each municipality and each national regulation and to analyze the overlap between these to come up with an approach that could be digitalized. We come up with 4 categories on how to compute the maximum building height. You can have how far you have from the minimum elevation level. Is it a terrain? Is it the main facade? Is it, etc., to the highest elevation level? Is it a roof? But then you have another category, for example, in Portugal, that, oh, you have to compute the maximum building height based on the surrounding building, the maximum and minimum, and then when it comes to the powerfulness of the geosite. The minimum areas, so to tackle how far the volume of indoors is checked and is computed. And we have one of the partners that is focusing, for example, on the room clearance check-in, is computing the from the floor to the ceiling height. Is it adapted to Prague regulations? based value constraints, for example. The example of buildability index is an ongoing process to how far we can compute or check the potential volume or rate that could be built. For some municipalities, it's based on the computations of the area rate than the volume. Then this challenge is to be tackled. I said 4, not 5 categories, because late these last 6 months, accessibility has been introduced as new category, but in more digitalized way automatically. So our partner Fraunhofer made a virtual assistance management tool based AI that was adapted to make sure that we can map automatically accessibility for the 4 municipalities. We didn't start in the project by the AI. I see that we have really not good quality for the slides. I wish that maybe it was the, but yeah, we have elements that was mapped from the IFC schema automatically, and it took for the project 3 weeks to make sure to analyze 39 clauses. This process was also analyzed with the non-automatic mapping parts for the regulation to make sure that the analysis behind has been taken into consideration. Coming to one of the important parts to exchange the data and to take in consideration the data from the BIM sites, not only AI has been used, but one of the important data exchange that has been implemented so far is IDS. We started in the project with MVD XML, but then many analysis has been done that the best choice to start with is the IDS, and our partner RDF has developed for each municipality an IDS that take in consideration the first preliminary results. For example, how far each building should have a type of construction, and how far we have the data requirement for the building height is there. But IDS was not enough in terms of machine readable format, so we annexed human readable format to the IDS itself, and where the data requirements and the modeling guidelines has been analyzed and implemented so far for the designers. For example, we have here, I'm really sorry that we cannot see in a good quality my slides. I wished so though, but I will explain it yeah. Yes. Thank you. So this is an interesting example because the requirement comes from the geo side. For this municipality, Ascoli Piceno, we needed that each facade is modeled in order to make sure we can compute the distances to the next building and to the next road. So these computations couldn't be done without having, at the early stage parts from the BIM side, some modeling enhancement that should be there. And one of them is how far can we have the facades modeled, because we have already the IFC wall. Then we said, oh, one of the analysis, this most suitable entity could be to group, because as aggregations, IFC grouping. But then at the level of the geometrical exports, it couldn't be done. It was challenging. So one of the things that has been done by our partner is to develop microservices as a kind of a small application that could make it possible to adjust for this need, the automatic extraction for that. One of the powerfulness also of the IDS is, since it's not enough, it's complemented by microservices, but other limitation was also in the expression power. It's less expressive than the MVD XML. Then we are really looking forward for the enhancement that could be done so far. One of the outputs also that was relevant in the project is how far can we use the IDS in the data exchange parts implemented from the software modeling parts from Revit to IFC. And here where it comes Diroots, who are our partners from Portugal, who developed a plugin that could do the automatic mapping. Here, as you see here from this part, the lowest part of the template, that could do the automatic mapping from Revit, and you can implement the IDS for each municipality. Based on this requirement, you can have the automatic entities and property sets that are there. This is an ongoing process. We have the early stage outputs from each municipality. We trust the process in a way that it can be iterative and monitored in a way that every time we go through the workflow, the enhancement go back, reported to the designers by the modeling guidelines. So here we saw in the example of the facades from distances that the geoside is needed, but how far do we need a city context? Why can't we convert from the geo parts, the building and the surrounding buildings to the BIM side, and to be content with this conversion in order to compute this rule chicken? That was one of the challenges that has been discussed at early stages of the proposal, but we make sure that if we want to compute with urban tolerances and the rule chicken that are related to the neighborhood, we need accuracy in terms of implementation. So here we are talking about CRS, we are talking about georeferencing, how accurately BIM models can be implemented in their surroundings. And that's why we developed in TU Delft a tool which is based also GitHub repository, but there is also a web-based application that you can also scan from here, that it's validating in the meantime and enhancing the georeferencing part. So if you go through the application, there is a tool guide. It's so easy. It's a drag and drop. You drag your IFC and you see if the two entities, IFC projected CRS data and IFC conversion data, are filled, and you will get either a wrong or right message that it's well georeferenced. You can also enhance the accuracy with the surveying coordinates, up to 3 possibilities, and it's also supporting the IFC 2x3 and IFC 4 version. From the BIM to Geo side, we have a second solution that was also developed by my teammate from TU Delft that makes sure the conversion can be done from the IFC to city standards. This application do the conversion through envelope extraction via OpenShell and also voxelization that parse the output and convert it automatically to CityJSON, which is JSON encoded for CityJML schema also. We used for that the definition of level of details. If you are from the geo side, TU Delft in 2016 developed definitions of LODs more detailed. So we can have LOD 1.2, 1.3, etc. And for each level of detail, we in research try, me and my team, to see how far we can enrich and to what level, to what extent we can enrich each level of details to the data requirements that are needed. If you see here, for example, LOD 3.2 is one of the accurate LODs that make sure that we have, for example, detailed windows are there. So for the geo computations, we need to make sure that IFCs are converted to LOD 2.2. But this is not the only challenge that is there, because from the geo side, we need also surrounding building to be at higher LOD. That's where it comes, the second part of this project, which are the implementation of this solution into each municipality context and also to a software vendor platform where this conversion could be implemented into the surrounding buildings. You see here the example of Ascoli Piceno that could be made to different level of details. We have LOD 2.2 with still some geometrical invalidities there, and the possibilities to have multiple LODs in the same visualization. The LOD 2.2 is the more stable at the roof parts and the envelope itself. That made sure that the alignment check-in could be done to the roofs and to the next neighborhood subjects. So this solution is open source, but it was also implemented into virtual city system platform through vSMAP, so that we can take the fullest potential of the solution and help into the conversion parts. As you see here from the surrounding buildings, they are not at higher LOD level, but one of the challenges was not to make sure that the surrounding is at highest level. One of the challenges was that we could have, from the IFC part, the plots and the site determined and separated from the building itself, and in order to make sure we can convert and filter details related to georeferencing and from the IFC to the city side. It was really a hectic process, but we made it through a decision to separate the files from the export from IFC and to make the terrain separated to the building, which is not really easy. We talked about how far we could extend IFC, and this is one of the challenges we have, the plots. But we have other challenges that I summarized in the lesson learned part. Here you can see that from the rule check-in, we computed at the level of the 4 municipalities the maximum building height. It's again not at a higher quality. I'm talking about level of detail, but in my slides they are not. Yeah, okay. Then one of the things that are so important in the slide that it's not the definition of the maximum building height at the building level, because here you see that depending on municipalities, you can compute it from the elevation of trees of the entrance or from the terrain level, but then you have also definitions that are different from each municipalities on the computation of the roof itself. Some of them, they define that you need to do the sum up of each elevation to have the, especially if you have different roof geometry, pitched roofed, or multiple height levels in the same building, like if you have extensions of the buildings, so we need to do the sum up. Some of the municipalities, they define the maximum building height as the maximum number of floors. So this is where we try to do for each municipality a different way of computing it. After I presented how far we made it through these 2 years into the project, oh, the lunch will not be served. So far for the lessons learned during the project, and I try to summarize, because you know, in a huge complex project like that, there are layers and layers of complexities that are getting out. So I put some few open questions that I summarize them as a letter to BSI. I put like a bottle letter to the water. So maybe it's gonna make sure that we have discussions after the session. I said that one of the challenges that we had is how far we can model elements from the IFC side to the geo side. IFC so far for the latest version, as we saw, that 4.4 is already there, and IFC 5 we've heard in 2 to 3 years. I'm not sure how far. I mean, to my opinion, maybe it's going to take more. But how far can we make sure that the outcomes of the Czech project's rule interpretation and check-in could be implemented in order to enhance how we model and take in consideration these best practices into extending IFC itself? From the Geo to BIM side, I didn't give it more time because with the squeeze time, the Geo to BIM side, we have challenges to how far we can model the surrounding properties. We use property sets for that, but how far are they gonna be a solution? And what is the next phase solution for that? Some of the other improvements that are needed to be done is in terms of IDS expressiveness. So I'm really curious to what's next. The possibilities are endless, and we don't have just the urban application of the digital building permits, but we've just had in few last weeks funding from NWO, from Netherlands, to have a spin-off to make sure that we extend the digitalization. It's at early stages, it's not yet technologically mature enough, but to make sure we develop a platform that takes in consideration data requirements for early stage design, for property evaluation assessments. And for that, we use the 3D bar, that is one of the 3D city models that are the outcomes of our unit. And we hope that we can make sure the next years to develop a platform that could implement the IFC model at early stage design into the surrounding building to assess visibility, indoor daylight, cost materials for the property value, which is the outcomes of my PhD research for the last 4 years. Thank you so much for your attention. I added just one QR code for a new application slide, Ask Me, because I see in conference like that, the rush of dopamine is there, but after that, we don't interact. So this is an easy application that makes sure that you contact the conference person to ask them about a specific point. So I will be really glad to exchange with you. Thank you.
Thank you, Siham. Wonderful work and yeah, brilliant session. So we heard a lot about the present in that one. Talking of the present, I think it's probably time to eat. So we're going to break for lunch now. So please exit out of the doors, keep going back past reception, take a left back round to the main hotel resort, and we'll have some people there guiding you through. So we'll go back to the buffet area for many of you that had breakfast. If we could try to reduce the lunch to 50 minutes, that would be to come back at 1:50. That would be great. We will start the next session. Sorry that we're a little bit late, just trying to catch up some time. So if we could just have 50 minutes for lunch, start at 1:50, that would be great. Thank you.